Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Now, this episode is going to be chocked full of lessons learned, I guess you could say, both for you listening and for myself. And I feel like I am going to morph into a graybeard by the end of this episode. Now, if you're unfamiliar with what a graybeard is, generally in the software development sphere, graybeards are usually the older folks that are software developers, and they get their name for, I think, obvious reasons. And they have this stigma around them that, you know, they've been around a while and they're super wise and they're like absolute legends of software development because, you know, these guys have been coding before the internet was born, so, you know, they actually know how to code, rather than us younger developers, where our coding knowledge comes from, sure, a little bit of actual coding background, but also our ability to search the interwebs and Stack Overflow, amongst other sites as well, to find ways to figure out what the heck we're supposed to do. But also, you know, back in the, you know, since they have so much, you know, development experience, you know, they've seen a ton of stuff, right? They've seen all kinds of errors and warning messages, and with all the experience they have, they pretty much a go-to solution for any young developer out there that's especially learning a new code base, or new to a company trying to learn the development practices, or just coding advice in general. Graybeards are definitely the wise ones. So I might feel like I'm turning into one by the end of this episode, because there was, oh boy, a lot of stuff to talk about for this week. But before we get into that, let's start with our trivia question for the week. So, Android Auto and Apple CarPlay are supported by a large number of auto manufacturers and cars in general, and is pretty much beloved by all users. Pretty much everyone that has a smartphone is able to use it, and they love it. Now, the trivia question is, which one came first, Android Auto or Apple CarPlay? And bonus points if you can get the year and or day and month as well. So you got a 50-50 shot on this one this week. So hopefully a lot of you will be able to get this one right. So that is your trivia question for the week. And speaking of this week, while it was a roller coaster full of ups and downs, I was listening to a podcast this week. I was listening to the Enterprise Linux Security podcast, which actually, I guess, came out not this week, but the previous week. I think it was like end of June was when it came out. And they were talking, of course, about the Red Hat situation like we talked about last week. And they had a pretty good quote in there, which I thought was kind of good. They said, "It's not funny, or an enjoyable situation for the enterprise, which is our audience who we're talking to." And of course, me listening to this, I was like, yes, I am the enterprise. You're talking to me. I am listening, and therefore, I am the enterprise. Obviously, I am the enterprise. I mean, of course, I have a server rack. I have a data center at my house, so I am the enterprise. Now, of course, as I say that jokingly, the irony is, I do have more infrastructure at my house, both in terms of physical servers, like actual, you know, desktops and rack-mounted servers and virtual servers, like with all the VMs that I run, than a decent amount of like small businesses, I would say. So technically speaking, I am more enterprise than some enterprises, I guess, depending on how large you consider enterprise to be. But I just thought that was kind of funny that they were saying, the enterprise, which is our audience who we're talking to right now, and just me, a guy with a Homelab, happened to be listening and was like, yes, my Homelab is the enterprise. So I just thought that would be fun to share. But now let's get into this week's cybersecurity tip. So this week's cybersecurity tip is another one that's not necessarily applicable to you necessarily immediately, and is a little more out there in the sense that I generally won't expect a lot of people to do this because how many extra steps you have to go through to do it. But like anything in security, generally speaking, the more hoops you have to jump through, the more secure the thing is, right? Like the more locks and doors you have to go through, generally the more secure the facility is going to be. Generally, the more levels of authentication you need to access the device, whether that's a password, some kind of multi-factor token, whether that's like a YubiKey or you have like an RSA token or a Microsoft Authenticator, Google Authenticator, Duo, some other app like that. Or you have some kind of biometrics. The more levels of security you have, generally the more secure something's going to be. Now, when it comes to maximizing your security online, of course, VPN companies would tell you to buy their service, and that's how you do it. But of course, as we talked, I believe on one of the first episodes of the Dark Assassins podcast, that's pretty much bogus. Now, the real way that you can be basically anonymous online is to use a tool like Tor, but specifically through an operating system like Tails. Now, the reason why Tails is different is you can go out and you can go out and download the Tor browser for any desktop operating system, and they even have mobile apps too if you want to put it on like your iPhone or your Android phone, and you can surf Tor that way. But the thing that makes Tails different is the Tor browser just routes all your web traffic through the Tor network, or the Onion router is what Tor stands for. So it routes all your web traffic through Tor, but Tails is different because Tails routes all your network traffic through Tor. So if you're connecting to, say, a remote server over SSH, for example, that SSH connection is going through Tor. Whereas if you had Tor on your laptop through the Tor browser, only your web traffic would go through Tor, and that SSH connection would just go through your normal ISP, or if you're connected to a VPN, through the VPN, that kind of a thing. So Tor routes all your traffic, or Tails routes all your traffic through Tor, and basically it assures that you're going to be anonymous, of course, assuming you're not, signing into your personal accounts on Tor, because as we discussed in that VPN episode, and multiple other episodes on the podcast, you basically are just giving yourself up and telling everyone who you are, like, hey, look, it's me. I'm in a different location, but it's me. By signing into your personal accounts. So assuming you don't do that, it's pretty much the gold standard for anonymity online. And there is a reason that Edward Snowden used Tails when he was doing all of his stuff back in the early mid-2010s, I believe. Now, whether you consider him a traitor or a hero, I think it's kind of besides the point, that he knew how to practice good OPSEC and keep his personal information and, just in general, he had good security knowledge to not get caught. Whether that's a good thing that he didn't get caught in your eyes or a bad thing he didn't get caught in your eyes, the fact of the matter is he was able to do it because of his knowledge. And part of the way he did that was through Tails. Now, another thing that's really cool about Tails is you can actually install it physically, like on your computer if you want to. Like, obviously you could put it in a virtual machine, or you could install it to the hard drive itself or the SSD. But generally how people use Tails is they just put it on a flash drive, because you can just boot from the USB flash drive into a live Linux environment, which is Tails. And you could literally do this anywhere. You could do this at any public computer that you didn't necessarily want to log into the public computer. You could just plug your Tails USB in and access Tails that way, through access Tor that way. The other nice thing about Tails is, while you can set up a permanent storage on there to like save some data for like long-term stuff, it's by default set to delete everything upon, shutdown or when you pull the USB drive. So basically everything runs in system RAM. So as soon as that computer gets shut off, all the data that was on there is just completely gone. So really good for privacy and security. And the other thing that's really cool about it also is because it's on, a USB stick, you could just, keep this on your keychain or whatever. And while you're carrying your normal computer around, if you wanted to do some anonymous browsing, you could easily just, boot up your computer, hop into the Tails environment on the USB, do what you want to do, and then good to go, done. So it's pretty cool for that. Now, I've talked about how it uses Tor. Now, I'm not going to go super in depth with, what Tor is, but basically, Tor is it's a protocol that basically routes all your traffic through a series of hops through the Tor network. So then when you come out on the other side, assuming you're going to the clear net or just the normal internet, you come out at some place that's obviously not your own. And unlike a VPN where you just make one hop to the VPN server and then out to the internet, the Tor network, you can make, like 3 hops, through different nodes in the network. And each hop that you make through the network adds an additional layer of security through additional levels of encryption. At each hop, there's a new level of encryption. So it's basically impossible for a hostile actor to have a relay in the Tor network and know what you're doing unless they have basically all the relays, because you're making multiple hops and the hops are randomized. So it's basically impossible for anyone to bust you, assuming you're practicing, good operational security and not giving out personal information and that kind of stuff. Now, it obviously still is technically possible, so you got to be careful about it. But it is a good tool for anonymity. Now, some of you might be wondering, isn't Tor the thing that cyber criminals use to navigate the dark web and do all their illegal activities? And yes, you're correct that Tor is commonly known for being the dark web, where a bunch of illegal activities occurs. But did you also know that Tor was initially invented by the U.S. Navy, specifically the Naval Research Lab, and was released as free and open source software? So there's a little bit of additional tidbit of trivia in there for you. But yeah, Tails and Tor is definitely a cool service. I have used both of them. They're pretty cool. Tails is a really cool operating system. It's basically just Debian, I believe, with, the extra layers of security. And also, for any of you super internet sleuths out there, it's currently not up, but on the dark web, the Dark Assassins Inc. has a little landing page that is on there that you could potentially navigate to. I kind of doubt you'll be able to find it. And literally it's nothing. It's literally just the logo, and it's like, you found our page. That's literally it. There's nothing to it, and it's currently not even up right now because it's on a server that is powered off. It was pretty much just a fun side project I did one time. But of course, since it's on the Tor network, it's a .onion site. The only way that you can actually access it is through Tor. But again, because it's not actually powered on, you couldn't access it anyway. But it is what it is. It's fun. So that is your cybersecurity tip for the week. Now, as far as nerdy stuff, I wasn't sure what I should do for this week. If I should say, my normal jingle, or if I should say something else. But to keep it in line with the theming of the podcast, what nerdy stuff have I been up to this week? Although, like I kind of mentioned, it's kind of more like, what projects did I break this week? But let's start with some positives before we go into the negatives. So, starting with the good, I did a lot more optimization in my video game project that I'm working on. So, I basically went through and revamped every single one of my switch statements I had, pretty much ripped them out and put in lookup tables. And I think I might have talked about lookup tables in the past on the podcast, but if I haven't, basically what a lookup table is you'll have something like for the example that I was using here, I was using a switch statement to check which value in an enum it was, and then based on what value it was, it would return a string that was the corresponding string equated to that enum. Now, that works, but from a code perspective and an optimization perspective, it's not very good. And the reason why it's not very good is because all the comparisons that have to go on behind the scenes and all the extra code that the compiler has to add into your binary in order to perform all those comparisons. Now, I can hear the argument being made that with how powerful computers are nowadays, are you really actually saving anything? And to answer that question, no, probably not in the grand scheme of things. But at the end of the day, it's optimization. Optimization's fun, and I'm kind of still of the mindset that while yes, computers are significantly more powerful than they used to be, and as such, it doesn't necessarily matter if your code is super optimized versus just generically optimized or whatever. Most people just, throw on the optimization compiler flags and call it a day, and in all honesty, that's probably good enough for, I'd say, like, almost every use case, although there are some niche use cases where you do need to pull every single ounce of performance out of a system. But at the end of the day, I think I've mentioned it before with this project, is that's kind of my goal of the whole project, is to make it as optimized and basically as optimized as possible and as efficient as possible. That's kind of the goal. And as I've talked about on several occasions, the complete overhauls I've done of certain parts of the code base, because I've realized what I thought was a good solution was actually pretty terrible and not optimized at all, and I found a much better way. And that's basically what the lookup tables were. So the point of the lookup table is, rather than me doing a massive switch statement and a bunch of comparison checks, what I can do is I can instead just create like an array of strings, essentially, and then have each element in that in that array of strings equate to the index value of the enum. So let's say, for example, since this is my Pokemon game, let's talk about typings. So we can say that, say, the fire type is equivalent to the number 3. So at index 3, you would have the string fire. So when you would pass in, when you wanted to do like a 2-string thing, you would pass in the type, which is the enum fire, which is the number 3. And then when you pass that into your array, you pass in the number 3. And at technically index 4, because 0, 1, 2, 3, that's 4 numbers. But you would put in 3 and you would get out fire as your result. So that way, you're essentially doing O1 time as far as computational complexity. It's one line of code. When you break it down into the actual assembly language, you're literally just getting an offset of the array, like the index of the array. You're just getting that offset and returning that. You're not doing a bunch of comparison checks and jumps in the code, none of that stuff. So as far as a code complexity and number of lines in the final binary in the assembly, you're gonna slash the number of lines by a fairly significant margin by doing a lookup table when compared to a massive switch statement. And personally, I also think it's a little more readable too, because if you've seen switch statements, when they get really, really long and the entire switch statement doesn't even fit on your screen and you have to scroll a ways to actually see the entire switch statement, it takes up a lot of room in your file there, and it's just not as nice as, a nice condensed, string of arrays, an array of strings of all your values, and then your 2-string method is literally a check to make sure the number passed in isn't out of bounds, and then you return the value, and that's it. It's super simple, it's very optimized, and a fantastic solution. So it's more readable, it's way more optimal, and it's just a great solution. And if you want proof that it's more optimal, what you can do is you can take basically 2 identical things of code, one implementation using a switch statement, one using a lookup table, and then you can either compile it yourself without any compiler flag optimization and look at the output in the binary, or you can do one of those online comparison tools where you can set which compiler you want to do, and you can compare the output between the compilers. You can do the same thing there too and see the difference between using a lookup table versus using a switch statement, and it's a fairly significant difference as far as lines of assembly code. And less assembly code means less instructions for the computer, which means more optimized, means more speed, means more better. Now, obviously, with how fast computers run, kind of like I mentioned, in all reality, it probably doesn't really make much of a difference, but here's to being as optimized as possible. Now, on the topic of being as optimized as possible, now we're going to start getting into some of the roadblocks, hurdles, things I broke, I guess you could say, portion. And that was, I made the mistake of trying to fix memory leaks again in the same video game. Now, when I say I made the mistake, I don't mean that in the sense that fixing memory leaks isn't important or a waste of time, because it's honestly quite the contrary. Because while if you're writing just a simple application that's just going to do a task and be done, Honestly, memory leaks don't really matter that much because as soon as your program exits, all the memory gets freed anyway, regardless of if it got leaked or not. Now, I guess one thing I should clarify for anyone that's not familiar with what a memory leak is, or whether that's you don't necessarily have a software development background, or you haven't done much lower level programming before with like pointers and memory allocation and all that stuff. Basically what a memory leak is and how it happens is you allocate memory and you don't free the memory. Now, when I say you don't free the memory, that can happen in a few different ways. So one of the common ways that like a memory leak can happen is, say that you allocate a pointer using like malloc or something, and then you never call free on that pointer to free the memory. Another way that can cause memory leaks too is if you create, say, 2 pointers, you allocate memory for each of them, and then somewhere down the line, you allocate that one of those pointers to point to something else with ever freeing the memory that it was initially pointing to. And because that memory was never freed and there's nothing pointing to it, that memory is now inaccessible and it can never be freed, and you have a memory leak. Now, there are certain languages out there, like Java, Python, the higher level languages, that have this idea of garbage collection, which is able to detect instances like that and clean up the memory for you. Now, this obviously comes at a performance hit because it's constantly having to check to see if there's any memory that's not accessible anywhere and can be freed. So there's obviously a performance hit there, which is why if you look at the speed comparison between something like Java versus a C or a C++, C and C++ basically run circles around Java. Now there's obviously other reasons for that. Java's running in the Java virtual machine rather than being compiled down to the actual assembly code that the instructions the computer can understand. It's running in the Java bytecode, which has to run through the virtualization layer, yada, yada, yada. But the point being that memory leaks can cause big problems. Now, like I mentioned, it's generally not much of an issue if you're just writing a simple program that does a couple things and then exits. But if you're writing an application that's going to be running for a long time or has a lot of memory accesses, doing a lot of allocating and deallocating memory, if you have a memory leak, while it might not be that much, depending on how much of these leaks happen, whether it's 4 bytes there, 20 bytes there, 3 bytes there, they add up over the runtime of the program. And if you're running something like a server, for example, that's basically supposed to have 24/7 uptime, that's a lot of uptime for memory leaks to happen. And because this memory is never freed and can't be freed until the program exits, you basically you can run into the situation where you end up hogging all of your system's resources, and there's basically nothing that you can do about it aside from restarting the program or even restarting the computer. So that's obviously not ideal. So obviously I wanted to nip this in the butt now while my code base is still relatively small. And I say relatively small. I don't honestly know how big it is at this point. It's been a while since I checked. But the last time I checked, which was, I'm not going to lie, kind of a while ago. And I have made a decent number of changes and updates since then. But I believe it was hovering in the neighborhood of around, something tells me it was somewhere between the 4,000 to 6,000 lines of code, which sounds like a lot, and it kind of is. But compared to how big this project's going to get by the end of it, it's still in the infancy stages. So it's better that I fix these problems now rather than when, basically the project's done and I'm like, oh yeah, I should see if I have memory leaks, and then basically the entire entire project is affected, and however many tens of thousands of lines of code or however much it ends up being, and that would be a royal pain. So I figured I'd try to get this sorted now before it gets any worse. So basically, my vendetta here of to get rid of the memory leaks, basically, how do I put this lightly? It basically turned my program into the software equivalent of a paperweight, and it's basically what it sounds like. I literally could not do anything. I would try to run a test case, it would crash. I would try to run another test case, seg fault. Basically, every single test case that I had already written to check the functionality of my program crashed. So eventually, I did get it quote-unquote working, although it still wasn't working because I still had memory leaks, but I at least got it back to the stage where I could actually run all the test cases and they would pass. Now, this whole saga took me longer than your typical 8-hour workday, which by a significant margin, by the way. And mind you, this was also after I had already gotten off of an 8-hour workday in which I was coding. So I basically was programming from the time I woke up to the time I went to bed, quite literally. And needless to say, I was kind of beat by the end of the day. I'm not necessarily going to say how long I was awake, but let's just say I didn't get 8 hours of sleep the next night, not even close. So basically, and the only reason I stopped was because my stubbornness could only take me so far. Because one thing that longtime listeners of the podcast might have picked up on, and even if you're not aware, I'll just tell you, when it comes to personal programming projects and just programming projects in general, the same thing happens to me when I'm at my actual day job. I can't, having unfinished code or code that doesn't work just does not sit right with me, and I can't leave the code in a state of being non-functional in good conscience. So part of me wants to get it to the point where it actually is working like it's supposed to before I can comfortably leave it for the day and, take a break and go do something else. Which is part of the reason why I was at this for well over 8 hours. And honestly, the only reason that stopped me was like I said, my stubbornness could only get me so far. And eventually I looked at the clock, realized it was 2 a.m, and I had to be up at 6 a.m. the next day. And I was like, you know what? I'm just gonna have to wave the white flag on this one, because I haven't made any significant progress in like the past hour and a half, and I am getting really annoyed and frustrated, and I honestly just don't see this happening. So I'm just gonna call it. Now, granted, I was not happy with that decision of calling it because I wanted to get this thing to work, but in all reality, I think it was definitely for the best that I made that call. Which, like I said, I did not like that decision and aggravated me. Now, it technically still works, like it's technically functional, like at least the code is not like completely broken, but it's not working like I wanted it to, and the whole point of this vendetta, if you will. So, but since I've had some time to cool off from that like 11-hour extravaganza, I realized that I should have been doing something to make my project work, and that was starting over from scratch. Now, when I say starting over from scratch, I'm not saying like throw out all the source code I've written, all like 4,000 or 6,000 lines worth, and start from zero again. What I'm saying is there's a principle that I have used in the past whenever I run into a roadblock like this, which is essentially to figure out what the issue is and implement the most basic version of that in like a test program. So in this case, we're dealing with memory management. So basically the goal is create a test program, super simple, super basic, that allocates memory and frees the memory and has a class that contains memory that gets dynamically allocated, and then upon its going out of scope or being deleted, that memory is then freed to prevent memory leaks. So that was the goal of this mini project, and before I actually started recording this podcast, I did actually get that mini project in a functional state and with zero memory leaks. So I was very, very pleased about that. Got to take the little wins where you can get them. But it's one thing that I've noticed that I've used, both in my professional software development career and my personal software development journey, is when I get stuck on something, I always find that if I just set the big project aside, or whatever the project I'm working on aside, set that aside and just implement the most basic version I can in just a simple test program and play around with it, hack it up, add a bunch of different scenarios, a bunch of different use cases for how this little basic scenario can work, and just try to master the concept and the understanding and really understand how it works. Because once I do that, then when I actually go to try to implement it in the more complex project, it becomes maybe not trivial, but it becomes a lot easier because I know what to look for. I know how to do the things that I'm trying to do at the basic level, and then I can kind of extrapolate that out to the more advanced concepts of the bigger classes in classes, that kind of a thing. So it definitely helps. So that time away from the project and the fog of war, if you will, because when I'm in the moment, and especially when I'm like 7 hours in to a coding extravaganza like that and stuff just isn't working, my mind isn't focused on let's do it the right way and do a small test program, get it functioning, and then bring it over to the main project. My mindset in the fog of war here, when I've been going at it for this long, is the project doesn't work. I want it to work, and I won't be satisfied until it works. So while, yes, the better solution is to go off and make a little mini project to get it working and then come back to this, I won't be satisfied until this version, the one I'm working on, works like I want it to. But at the end of the day, that is kind of some graybeard advice, if you will, is if you ever find yourself in a programming project where things just aren't working and you're trying to implement a concept, whether that's networking or whether that's pointer operation or memory allocation and deallocation, whatever the case may be, it's best to implement the most basic version you can think of first, and then maybe scale it up a little bit in that same test program and really understand the concept of what you're trying to do and the operations of how you have to implement that feature before you then add it to the more complex program you're working with, right? I guess it kind of comes back to that crawl, walk, run thing, right? Like you can't take this massive project and expect to be able to run with it right away on some concept you're not super familiar with or have a lot of experience in. You have to start at the crawl phase first, build up that knowledge, build up that experience with the whatever you're working with. In my case, memory allocation and deallocation and memory management in general, and then scaling that up to the larger project and incorporating it in there. So that's some advice for you for there. And then a little also, funny enough, in the same vein, this other thing I'm going to talk about also has to deal with this project, although this also kind of sort of has to deal with my Homelab too, because it was part of the Homelab. So I got to experience some of the joys of GLIBC. Now, if you're not familiar with what GLIBC is, it's basically the C standard library. So if you're running a Linux system, there's the C standard library, which is a collection of shared libraries, which virtually every program that's running uses and accesses. So it's a pretty big deal. And currently, the graphics library that I'm using, Raylib, the version that I have, it was a precompiled library that I downloaded from their GitHub page, because the reason that I pre-downloaded the library was I wanted to make my source code and my project as portable as possible. Like, I didn't want to have to install Raylib on every single one of my computers that I wanted to build my code on. I wanted to just be able to download my source code and be able to build it right there and be able to run it without having to install anything else. And this worked until one day this week I decided to try to build it on one of my Red Hat systems. And that didn't work. And I was wondering why it didn't work. And I got this really strange error message saying it was looking for glibc 2.3.2.35. And it was looking for like some I guess function that's included in that version of glibc, and it couldn't find it. And I was baffled by this because I never saw that error before. And I was doing some looking around online, and basically the answer was the version of glibc you're running is too old, which is kind of funny because the newest version of glibc right now, at least as of recording, is 2.37, and the version that was the Raylib library that I had was 2.3.5, and the version that Red Hat has that I was using, which, mind you, is Red Hat 9, which is the newest version of Red Hat, and that only had 2.3.4. So in classic Red Hat fashion, they're using older versions of things just in general because generally, for stability and all that kind of stuff. So that was definitely a bummer. Now, I was trying to figure out a solution around this, and if you think initially, one of my initial thoughts was, okay, I'll just install a newer version of glibc. Well, that's not going to work because everything on the operating system revolves around glibc, so if you mess with that, you're basically going to brick your system. So I had seen some people online trying to have two different versions of glibc, but I kind of tried doing that. That was a complete nightmare. So basically what it comes down to is if your version of glibc isn't compatible, your basically only option is to have a super hacked up solution. Pray that whoever manages your Linux distro is going to give you a new version of glibc soon, or just distro hop to a new distro. Those are kind of the options. So eventually, after hours of troubleshooting this and tinkering with this and trying to get various versions of glibc installed on the side, I again waved the white flag. Now, I can already hear, I'm sure that there's someone out there that's listening to this and is currently screaming at their device right now that they're listening to this podcast on, saying how simple of a fix this is and how much of an idiot I am for not knowing the solution. And you are very much correct, and I did actually figure out the solution, but we're not quite at that point in the story yet. So later on that evening, where I had previously waved the white flag, I then, of course, came to the realization that I am indeed a complete idiot. So basically, I was perusing Raylib's GitLab page because I was wondering if there was anything on there in regards to the GLIBC version, like if there was like a requirements thing, like you need to have this version of GLIBC. And then, of course, I didn't really find that, but more so, I was perusing and I saw the different various platforms that you can do Raylib on: Linux, Mac OS, Windows, Raspberry Pi, all the various kinds. And I saw the thing of how to build the libraries, and I was like, wow, I am a complete idiot. I downloaded the precompiled libraries from the Raylib GitHub page, so whoever compiled them, I guess, was using glibc version 2.35, which, if I had to guess, the Linux version was probably compiled on Ubuntu, I think 2204, since that's the version of glibc on some of my Ubuntu 2204 servers that I'm running. But regardless, they compiled with that version of glibc, and this is where I, of course, had the realization that I'm just a complete idiot, and all I literally have to do to fix my problem is to just compile the library myself. And of course, as soon as I did that, all my issues were fixed. So I literally spent hours on, I don't remember what day it was this week, trying to troubleshoot an issue that was not an issue. Literally all I had to do was, as the Arch users would say, RTFM and read the wiki. Because if I would have just looked at the GitHub page and read the instructions, I would have seen that I could easily just, build the library myself. And of course, as soon as I did that, it fixed all my issues. So, yeah. And this is actually, I think, at least part of the reason why generally when people ship their source code for their software, they almost never include the libraries, or if they do, it says it's a separate thing and it's not like included in the repository itself. And this is for a couple reasons. Obviously, you have this reason here where the library version just might not be compatible because the system it was compiled on, so you'd have to have potentially a bunch of different versions of the library, and obviously you'd have to have different versions of the library for each OS type you're planning on supporting, so that's obviously a lot of bloat in your repository. And the other thing too is, generally speaking, libraries are quite large. Now, thankfully, the Raylib libraries are pretty small. I think they're only around like 2 megs or so. So they're not like huge. But obviously, compared to just straight up source code, they're pretty darn big. And even like my fully built executable pales in size compared to the library. So obviously, they're quite large in comparison. But as far as in general libraries go, they're actually not that big. Which is part of the reason why I have them in my repo, but also, like I mentioned before, I want to just be able to download the source code from my repo onto any one of my personal computers and just be able to instantly be able to not only build, but also run my program too, to be able to test it and play around with it and all that good stuff. Now, that was another problem solution talk. Now, I guess this kind of brings up a good segue into why do I constantly talk about all the various problems that I have both on my programming and my Homelabbing in general. And if you're wondering why I spend all the time explaining my incompetence and wasting hours of my life on, in some cases, very simple fixes, like in the case of the library that I just talked about, it's because that if I didn't do that, I would essentially be lying to not only you, the listener, but also to myself. Because anyone that's played around in a home lab or done software development knows this is basically inevitable. You're going to run into a situation where you're trying to go, you're narrow focused, trying to go down one of the rabbit holes, realize it's a dead end, back up, go down another rabbit hole, realize it's a dead end, and etc. until you actually find the solution. So I've had this experience both in home lab stuff, playing around with servers, trying to, install things that don't work or things that aren't compatible. Obviously, I've had it happen many times in my software development journey. But another reason why I think it's important is because I've mentioned it before on the podcast, and I'll mention it again. The main reason, or one of the main reasons, why I talk about the software development projects and the home lab projects I do is because that's what gives me inspiration to do projects. And not in the sense that me talking about them does, but when I hear other people talk about various home labbing projects they're doing or various programming projects they're working on, that gives me inspiration for ideas that I can do in my own home lab or for software that I can write. And that gives me inspiration. So the goal of me, talking about these various projects that I work on is to hopefully inspire some of you out there listening to do a programming project or to, do some home labbing project or just get into, one of these hobbies, because it is, while I oftentimes, talk about, all these struggles and how annoyed and angry I sometimes will get and how frustrated I can get. At the end of the day, there's a reason why I continue doing it, because overall I really enjoy it. And I hope that there are you out there that also enjoy it, and I can potentially inspire you to be able to go and pursue that. But if you've never done any kind of home labbing or software development before, and I was only telling you about the positives, again, that'd be disingenuous, and I'd essentially be lying to you that of how great it is and only telling you about the upsides. So it's basically like I would be that, I'm putting this in quotes, social media celebrity, that they only post that, of course, their life is perfect and everything they post is about their perfect life, but everyone knows that behind the scenes, it ain't that perfect. So just like, it's the same thing with software development and home labbing too. While the end products can sometimes look really awesome and look super polished, there is a long, windy journey that you took to get to that destination. That journey wasn't necessarily so pleasant. Lots of frustration, lots of maybe wanting to throw your computer out the window or maybe your data center out the window. There's a lot of twists and turns that goes before you get to your destination. It's not the simple crow flies to get to that destination. It's the windy back roads to get to that destination. But honestly, the journey is all part of the fun. And to the point also, while you will encounter a lot of failures, but the nice thing about encountering a lot of failures is that's honestly just a bunch of learning experiences for you. Because now I know if I ever encounter an issue where I'm using a library and I see some GLIBC error, I know, all I got to do is recompile that library and I'll be good to go. So when you encounter these issues and go down rabbit holes, it builds your knowledge base in order to know how to better approach problems in the future, and adds, more tools to your toolbox, if you will, on how to go about solving problems. Because, at the end of the day, if you solve the problem, it doesn't matter if you got it instantly, or if you took a few tries to get there and went down a couple wrong dead-end paths. at the end of the day, if you went down the wrong dead-end paths, some would argue that you actually ended up learning more in that process, partly because you learned what not to do, but you also learned why the way that actually works compared to the other options that you were trying before. So there's definitely a lot of learning that can go on through your failures and in my case, certain incompetencies of being stubborn. So there's definitely a lot of learning opportunities here, which is also why I talk about all the problems that I have, because maybe me talking about the issues that I run into in some of the projects that I work on maybe you can live vicariously through me and not have to endure those same hardships and see, some of the potential ways to not go about solving a problem and why those ways are not the way to go about doing it. So that is part of the reason why I like to talk about the problems I encounter and talk about not only the good stuff, but also the bad stuff too, because the bad stuff is as much part of the journey as the good stuff is. And also, like I said, there's a lot of trials and tribulations that go on behind the scenes, and me projecting that, doing a Homelab project or writing software is all glitz and glamour, and there's no downsides, no hard problems that you'll encounter. Everything's just super easy. That would be very disingenuous. There's that. Now, I think that's probably about where I kind of want to wrap it up. I guess the other thing I will say before that, because when it comes to things in software development as concerned, errors and problems you'll run into, I mentioned, while the finished product might look nice, anyone that's written software knows that there's, just because the software ends up looking very nice, there is a lot of, researching, a lot of debugging, a lot of time, wanting to throw your computer out the window, like I mentioned. There's a lot of stuff that goes in behind the scenes. And the same thing with like Homelabbing too. While your 10 gig network, might be fantastic and you can easily zip files, between systems, no problem, that doesn't encompass, maybe you tried to put in a 10 gig card into one of your systems, but it wasn't compatible, or, the firmware was bad, or the card was bad, so you had to buy a new one. There's a bunch of things that can go wrong in something that might seem so trivial, or that you don't necessarily see when you're looking at the finished product. So I kind of want to, give the other side of the coin to give you, I guess, a more genuine experience of what you can kind of look forward to with this amazing hobby that is Homelabbing, and the amazing career path. Well, I guess career path too, depending on how you go about doing it, as well as software development. So I want this to be kind of like an inspiration for you, and for anyone out there that is dealing with, problems with things not working in their Homelab, or running into errors in their software development and their programs and whatnot. Don't give up. Use those failures as maybe inspiration, but definitely use them as learning experiences too. So you can continue to build your knowledge base and continue to better yourself as either a Homelabber, a software developer, or possibly both. So with that monologue aside, let's get back to the trivia question. So this week's trivia question was talking about Android Auto and Apple CarPlay, and specifically, which one of those came first? Was it Android Auto or was it Apple CarPlay? And if you said Apple CarPlay, congratulations, you are correct. And one thing that I honestly found quite interesting about them was the dates. specifically. So I remember I mentioned bonus points if you get the dates correct. So Apple CarPlay launched on March 10th, 2014, and Android Auto launched almost a year to the day afterwards on March 19th, 2015. So obviously not quite to the day, 9 days off, but pretty darn close in the same month, and just a year later. So that was the trivia question. Hopefully a decent amount of you got it right, since you had one or the other. You had a 50-50 chance this week. So hopefully some of you got it right. And if you enjoyed this episode, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. And definitely be sure to share this one around to friends and family, especially the software developers and Homelabbers out there. To kind of have them get a better understanding that just because you might be failing a lot, that's not a reason to give up, and to use that as a learning experience. And if you have any questions about this episode, or you have any topics or questions for potential future episodes, you can shoot me an email at contact@darkassassinsinc.com. There's a link down in the show notes below for that. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.